Hi, I'm Alistair, and in this video we'll be building further on tutorial 2 by adding LLM agents which are able to call MCP tools. Dedoctive's hybrid approach allows for agents to be inserted into BPMN workflows. This gives the flexibility of agents along with the simplicity and control of traditional BPMN workflows. As mentioned in tutorial 1, we use the MCP standard for defining and calling tools, and Google ADK for developing these agents. In Designer, this is done by adding LLM agent tasks. In these, control is handed over to an LLM, which can then decide which predefined tools to use to complete its task. So, to begin with, we'll start from tutorial 2 and rename the process name to tutorial 3. Now, we'll delete and replace the simple script with a service task. So again, we'll choose the spanner here and choose service task. We're going to name this LLM Agent. Now, because it's a service task, you have to choose which type of service task it is. If we go into deductive service properties here, we can choose the operator ID. There are multiple different service tasks here, but we're just going to choose LLM Agent. Now there's an option for a response variable. We're going to set this to LLM response. This response variable can be used in all service tasks and is used to decide the variable name that will be set for the response from the service task. So in this example, whichever response the LLM gives will be saved in a variable of this name in task data. Now we will open the MCP editor. Here you can see an error message come up at the top. No MCP config defined in the MCP server config. We will get round to that in a minute. For now, we'll look at the settings available to us here. So we've got the model, which is the LLM model used by the agent. We'll set this to be Gemini 2.0 Flash. This is dependent on the API keys that you've added to Deductive Developer Edition's environment variable file. Now you can add an instruction. I'm just going to set this to be "You are a helpful assistant that can answer any questions." This is quite a basic instruction, but will do for this example. And as there's no tools available at the moment, we'll fix that now. If we save this, we can then click the blank canvas and go to MCP Server Configuration and launch the editor. This gives us the ability to add MCP servers which will be used for their MCP tools. So for example, you can see that I've already entered the details for a public MCP server. This is an MCP server that just gives you tools that give you the ability to request information about GitHub repo. The server name is Wiki, the transport method is HTTP, and the server URL is here. I'll provide this in the description of the video so you can copy and paste it. I'm just going to save this here, and you can see that it's now in the MCP server's configuration. Now if we go back into the LLM agent and launch the editor, it will now fetch the tools using that server we just added. Now you can see a list of tools available to us. These ones up here in the built-in section are ones built into Deductive and can be used without an MCP server. We're not going to use them here though. Here we're just going to select DeepWiki and select all of the tools. You can see that there are various tools for getting a list of documentation topics from a repo, for documentation about a repo, and asking any question about a repo and getting an AI-powered response. We'll save this and you can see in the parameters that they're now here. Now that we have the LLM agent set up, we want some way to enter a query for the LLM agent to respond to. We're just going to edit this user form to do this. If we launch the editor and edit this, we'll change the object name to be query and the display name to be query also. If we change the input type to be short answer and then change the description to be enter a query for the LLM to answer. And as you can see, this is in the form preview here. Remember to save here, and I'm going to save this in the workflows directory. Now if we run it, it will go through to the user input here. Any user form is flagged as a user input, and this means it will be automatically provided to the LLM agent. So here I'm just going to ask what folders are there in SciPy/SciPy. This is a public GitHub repo. If we send this to Deductive, this then goes to the LLM agent. It calls the respective tool and will give us a response. If we click the LLM agent task now that it's completed, we can see a few events get highlighted in the workflow output. These are all the events associated with this task. Here you can see that the LLM agent decided that the tool to call was called ask question, and it received a response from the function, and this is the event which is emitted at the end of the task being executed. If we open this executing ask question event, here you can see the event that was created by Google ADK. If we open the content, parts, 0, function call, you can see that the LLM agent did a call to a function called askQuestion, and the arguments were SciPy and what folders are there in SciPy. If we go back into the editor of the LLM agent, we can see that one of the tools that was given to it was askQuestion. This asks a question about a GitHub repository and gets an AI-powered response. So essentially what we've done here is ask the LLM agent. It has decided to use this tool, which also gets information about the repository and uses an LLM to get the response. If we open the output again and go to the received response and expand this, we can see that the function response includes a response and includes structured content. This includes the response from the tool. However, this is deeply nested, so an easier way to view this information is to go into the following event. This one is emitted by the task itself, and inside task data here you can see LLM response, which contains the same information. This LLM response is because we set the response variable here, so the response from the LLM was put into the task data here. Now you can see we have a complete workflow which prompts the user for a query and gets a response from an agent, which decides on the MCP tool it wants to call. Because we use MCP here, tools from any MCP server could be used instead, which makes this simple workflow very powerful. As instead of just summarizing a repo, we could have had an LLM agent, which instead is able to request weather data, create Google Calendar events, and so on. That's all for tutorial 3. In the next tutorial, I'll show you how to call an MCP tool directly as part of the workflow.